right. First part here of normal distribution and the empirical rule. We're doing this in two separate videos here. So if you're looking for the empirical rule, you'll want to look for part 2. For part 1 here, we're going to do this real quick because it's a real simple concept. When you normally distribute something, okay, it looks like a bell curve. We'll get deeper into the percentages of things with that, but basically you have an average or a mean in the middle, and you have half of your data on each side, okay? So again, the maximum of your curve would occur at the mean. Mean, median, and mode, probably about the same. But again, when we're looking at the graph, this curve never makes it to the x-axis. Like, we're going to have like 99.985% of the material here, just that one little bit. And so we're going to talk about this thing called the standard deviation in the next part on figuring out, well, what percentages typically are going to be in each part of these halves, but that's for a little later. And so what we're going to look at now is your distribution. Now, it's continuous, okay? Again, if it looks like a bell curve, it looks symmetrical, it's normal. If, though, you get a bunch of data on one end or the other, so in this case, if you get a ton of data to the left and your tail is going off to the right, so your really long skinny part is going off to the right, sort of like positive infinity almost, it's going to be positively skewed. If I have all this data that I'm working with and most of my info is on the right-hand side and my little skinny tail is off here to the left, like you're going to negative infinity, it's negatively skewed. That's the easiest way to keep track of this. And so what you can do to figure out if your information is normally distributed or positively or negatively skewed, one way is to either take a chart like this or a histogram, a bar chart. And so when you do that, you look at the frequencies. Sometimes looking at it visually can make it easier. And what I did here was I just basically made a curve connecting all of the tops of all of these. And you can see that looks pretty normal, okay? Even if I looked here, most of my information is in the middle. If I were to combine what was going on to the left of the middle and the right of the middle, that's pretty close too. I don't see a large swing either way. So I could probably tell that this was normal even without the histogram. Now, let's actually do one here. So let's see. Let's go through and find all our 22s. So 1, 2, 3, 4 of those. 24, we got 1, 2, 3, 4, 5. Got that. 25, we got 1, 2, 3, 4. 27, 1, 2, 3. And 29, 1, 2. So if I do what I did before and I kind of just run over the tops, this time more of my data is here to the left. My tail goes down to the right. So when my tail goes down to the right towards, like, we'd think positive infinity, I'll spit it out. That's going to be positively skewed. Even if I'd have looked at this as a chart, and I was like, I got 4, I got 5, I got 4, I got 3, I got 2. There's the center piece, or the center area. I got 9 on the left and 5 on the right. I'm more heavily weighted to the left. More heavily weighted to the left. Okay? And so this bottom one, I went ahead and I did that for you. I went ahead, I made all my bars. Well, this one was real easy to see. Like falling off a cliff here. Almost all of my data is here on the left. I mean, if I split this up, there's like 4 here, 26 here. I mean, that's a massive skew on this side. And where's my tail? My tail's down here on the left, heading towards the negative. We'd have negative skew. That's it on this part. The rest of it, we'll be working into the normal distribution and doing a little math with that. And we'll see you next time.